Welcome back to my course Aspects of Biochemical Engineering. In the last lecture, I tried to cover the immobilization of enzymes. This will be continuation of that. Now, you can remember in the last lecture, I tried to define what do you mean by immobilized enzyme. Actually, immobilized enzyme means you confine the enzyme on the solid matrix. That is called immobilize the enzyme, and it has several advantages. Advantages means you can reuse the enzyme again and again, and stability of the enzyme will be increased to a great extent, and the purity of the product will be more. In industry particularly, it has lot of applications. Now, question come that I try to discuss in the last lecture that in this immobilized enzyme system, what are the different applications we have. I told you it has application, and particularly in the industrial sector. I can give the example of production of high fructose corn syrup. This is produced, particularly this is used in the western country in the confectionery industry. How it is produced? They use the glucose they obtain through the hydrolysis of starch present in the corn, and then pass through the immobilized glucose isomerase enzyme, and then glucose is converted to fructose, and we know the fructose is 10 times sweeter as compared to this is usually recommended for the diabetes patient. Not only that, if you look at beer making industry, one major problem with the beer making industry is the precipitation of protein, because beer is considered as the energy rich drink because it contains lot of protein. Now, and beer usually served under chilled conditions, and we know protein, if you heat it or cool it, there is a possibility of precipitation of protein. Now, if there is a precipitation of protein, then there will be haziness in the beer, which is not acceptable. So, what we can do? We can have the immobilized protease enzyme, proteolytic enzyme column, and pass the enzyme through, plus the beer solution through this, so that protein present in the beer can be disintegrated into the smaller protein molecules, which cannot be precipitated at a low temperature, and we can get chill proof beer. Now, divided into two different classes, one is called porous and non-porous solid matrix. Now, in case of porous, we have more surface area, and if more surface area is there possibility of more immobilization of more enzymes, and if more enzymes are immobilized, then we can expect more substrate conversion. So, we can expect more product formation. Am I right? And so, question comes, what should be the characteristics of the solid matrix? So, this we discussed in the last lecture. Now, this lecture I shall concentrate mostly on the methods, techniques of immobilization technique. What are the different techniques? Now, if you look at the first slide, it gives the that classification of the immobilization method. So, this immobilization method can be divided into two different ways. One is called insoluble enzymes, another is called soluble enzymes. Now, in case of insoluble enzymes, it can be, and the immobilization can be done in two ways. One by binding, another by entrapping. Now, binding means what? Binding means, suppose this is the solid matrix and your enzymes is there. So, this is bind, you are on the solid. And entrapping means what? Entrapping means, suppose there is a gel. Inside the gel, your enzyme are entrapped like this. There is a fiber, there we have fiber like this, and inside the fiber, the enzymes are immobilized. So, that is called entrapping. So, so if you look at the bindings, we have different types. One is cross linking, another carrier binding. So, this carrier binding again divided into 4 different classes. One is physical adsorption. Physical adsorption is a very simple technique, and cost involvement in this process is quite less. Ionic binding, through the electrostatic force of attraction, can be done, and another is metal binding and covalent binding. Entrapping, we have gel entrapping. I just showed you gel entrapping, then fiber entrapping, and microencapsulation. Microencapsulation, we know the envelope. Inside the envelope, the enzymes are immobilized. Then we call it microencapsulation. Very small that capsule we can put it. I can give the example of that capsule that we use as the medicine. That how the medicine is put inside the capsule. Similarly, enzymes we can put inside the capsule. Now, in case of soluble enzymes, the immobilization can be done in two ways. One is called ultrafiltration, and another is hollow fiber device. So, this is ultrafiltration means it is the membrane size will be very small, so that the enzymes they adhere on the surface of the solid matrix. Now, matrix entrapment. Now, when you talk about the matrix entrapment, enzyme solution is mixed with polymetric fluid and then solidified into various forms depending on the applications. Then I can give the example that calcium alginate, because we know that sodium alginate solution, here inside the sodium alginate solution we can put some enzymes, and then when you put drop by drop on the calcium chloride solution, we will be having bead formations, that is calcium alginate. So, your enzyme will be entrapped inside the bead. Now, polymetric material or semi-permeable and large molecular weight enzymes cannot be diffused out, but smaller substance and product can diffuse in or diffuse out. Matrix entrapment, we have calcium alginate, agar, kappa carrageenan, then polyacrylamide and collagen. Now, this is the kind of example of matrix entrapment that I showed you. This is the matrix. You can see this is the matrix, and inside the matrix how enzymes they are entrapped. This is clearly this is visible. Now, there are method of entrapment is infusion in the gel. One is infusion in the gel. Enzymes are entrapped inside the gel. Inclusion in the fiber. Inclusion in the microcapsule. I hope I have explained that. I don't like to spend more time here. Now, membrane entrapment. I talk about that particularly in case of soluble enzyme. There is a hollow fiber unit have been used to entrap the enzyme solution between the thin and semi-permeable membrane. So, you can see here the hollow fiber, this is the hollow fiber, very small fiber, and inside this fiber the enzymes are entrapped. So, this is the membrane material, maybe nylon, cellulose, polysulfone and polyacrylate. The acrylate, so different type of membranes we can use. Now, microencapsulation, this type of immobilization that enclose the enzymes in a membrane capsule. The capsule should be made of semi-permeable membrane like nitrocellulose or nylon. In this method, the effectiveness depends upon the stability of the enzyme inside the capsule. So, so your capsule, when you inside the enzymes, that now this capsule, that envelope should be stable. If it is not stable, then it is break, then enzyme comes out, or it disintegrates the enzyme. So, stability, the effectiveness of this this capsule is very important. Now, this is same what I have shown here. This is pictorially how it can be shown like this. Now, what are the advantage and disadvantages of this entrapment technique? First advantage is that it is a highly soluble, stable, because since it is inside this that if you pass the liquid here, that it is not going to affect the enzyme much. Only the substrate will diffuse, reacts with the enzyme, and product will burn, product will comes out. The substrate will go in and products will comes out. Easy handling, it is, you can, because I was in IIT Delhi, and one of my research colleague, he was working on immobilized glucose isomerase enzyme, and he used the collagen membrane. The inside the collagen membrane, suppose collagen membrane is a membrane, so this we can make it in the form of bag. We can fold it, and then with the help of heat we can seal it, and then one end we can put the dry powder of enzyme and seal it again. Like this we have different bag, and we can, suppose this is the column and of the reactor, in the bag we can put it here one after another, and we can pack the column, and then you pass your substrate here and get the product in other end. So easy to handle, no chemical modification is required, because no interaction between the solid matrix and the enzyme. But disadvantage is that enzyme deactivation may be possible due to maybe your matrix has some kind of material which affects the active site, then deactivation will take place. Enzyme leakage through the pores. If the pore size of the capsule is more, then enzyme may percolate out from the system. Now, adsorption technique, that this technique largely used by the industry, and this is the most simplest method of doing this, because what we do, you pack the solid matrix in the column, and we pass the enzyme solution. I can give a very simple example here. Suppose this is a column, and inside this column we have any kind of solid matrix. We can put it. We can, as for example, we can use a coconut coir. Coconut coir is a fine fiber. We can pack the column. Why we use coconut coir? Because it has lot of surface area. So more surface area, more will be the immobilization of enzyme. Now what we do? We prepared the enzyme suspension solution. This is enzyme solution. Am I right? Now this enzyme solution, with the help of pump, we pass it through this, and we recycle back to the system. So we just recycle this, and time to time we draw the sample and find out the activity of the enzymes. Now when the activity of the enzymes is constant, then you assume your column is saturated with enzyme, and then you keep it in the buffer for some time, and then you pass you replace with your substrate, and put your substrate here, and then you can take out product here. Very simple, very easy to operate this system. So here this is the physical phenomena, because here, suppose this is the solid matrix, so enzymes just they adhere on the surface of the enzyme, just adhere, it touches the surface, and the interaction between the solid surface and enzyme is due to weak van der Waals type of force. So if we pass the liquid at the very high flow rate, then it will be having some kind of shear force, and with the shear force there is every possibility enzyme may dislodge from the surface of the solid matrix. So that is the one problem. The attachment of the enzymes on the surface support is weak van der Waals type of force. Active site. Now when we do this kind of immobilization, one thing we shall have to take into account, the active site of the enzyme should not adhere with the solid surface. Now if it is the other way, suppose this is, and your active site is like this, then your substrate cannot interact with the enzyme. So that is not desirable. So that we shall have to take care that when you do the immobilization, the inactive site of the enzyme should take part for the immobilization of the enzymes. Now, desorption of the enzyme is the common problem, as I mentioned, and solid support material like alumina, silica, porous glass, ceramics, and diatomaceous as clay, bentonite, and organic material like DAE, cellulose, starch, activated carbon. The different type of solid matrix can be used for the immobilization purpose through the adsorption techniques. Now, this is how it adhere on the surface of the solid matrix. This is the solid matrix, and just enzyme simply adhere on the surface of the solid matrix. Now, the advantage of this process is that it is very simple and economical, limited loss of enzymes, and reversible process. And that here the reversible process means you dislodge the enzyme, again you can adhere, you can immobilize the enzyme on the solid surface. Now, the weak bonding, this is the major disadvantage. The low surface area for the binding, because usually that we use the external surface for the immobilization of the enzymes. So, it depends on the how much surface is available, and sensitive to pH, ionic strength of the reaction solution, and temperature. Next is covalent binding. Now, covalent binding is considered as the strongest binding between the, suppose this is solid matrix and this is the enzyme. Now, this bonding, and we call this covalent bonding. How the covalent bonding take place? It is the kind of sharing of the electron. So, one electron from the solid matrix, one electron from the enzyme, they are sharing with each other, and then they form the bond, and this is very strongest bond. So, so retention of the enzymes on the support, covalent bond formation between the functional group of the enzyme and those of the support surface. So, this is I can give the example of CMC cellulose, carboxymethyl cellulose, that is largely used for immobilization purpose. Now, here that functional group may be amino group, maybe carboxylic acid group, maybe hydroxyl group, maybe sulfur hydryl groups. This functional group must not be in the active site. So, as I mentioned in case of adsorption phenomena, that your active site should not take part for the development of covalent binding. Now, this is one example that I have given here, that I think it will be very clear. This is the solid matrix, and this is the protein. How protein, this is protein, nothing but protein, the enzyme nothing but protein molecules, and this is how adhered on the surface on the covalent binds with the solid matrix. This has been shown here. This is the functional group support material, usually activated by using the chemical reagent sizes such as cyanogen bromide and carbodiimide and glutaraldehyde. Now, one disadvantage of this process, that when we use any kind of covalent bonding, we use lot of chemicals, and due to use of a lot of chemicals, there is every possibility the enzymes will lose its activity. This is the one major drawback we have as far the covalent binding is concerned. So, this is kind of example that this is the bond, covalent bond I showed you before also, and this is the chemical reaction. This, let me explain that one or two. This is the carboxylic acid group, am I right, in presence of this methyl alcohol and this hydrochloric acid. The methyl group will be attached, and this is hydrazine. Hydrazine, this when it reacts, there hydrazide formation is there. This is called hydrazide. Now, this when undergo the diazo reaction, it comes the azo group, what I call acid azide. This acid azide, when it reacts with the amino group of protein, it forms the CONH that into protein. So, this is the how they can covalently bind with the solid matrix. Now, you can see how many steps are there. You start with methyl alcohol HCl, then hydrazine, then you have sodium nitrite, then pH you have to maintain 8 to 9. So, there are so many different steps are involved for this covalent binding process. So, what are the advantage and disadvantage? They are highly stable, no leakage, and a wide range of carrier matrix are available. Now, these processes are very costly and complicated. Low enzyme activity. Why low enzyme activity? Because during the immobilization, the loss of activity of the enzyme will take place, and high risks of modification of the active site. Because since you are adding a lot of chemicals, there is every possibility of the modification of the active sites. Now, cross-linking, another very interesting technique, what we call cross-linking. Cross-linking means, suppose this is like this. This is the enzyme that that this is cross-linked with other enzyme. This is the other enzyme. Like this, you can see that how they are cross-linking. So, I can explain like this. I think your conception will be a little bit clear. That suppose this is the enzyme. Am I right? And this is another enzyme, this is another enzyme, this is another enzyme, like this. So, this is like this, they cross-link with each other. So, we use some kind of cross-linking agent which hold the enzyme together. This enzyme holding this enzyme and this enzyme holding this enzyme and so this is called cross-link. Now, in the inside, if you put some kind of solid matrix, then what will happen? This will be embedded on the surface of the solid matrix. So, this is no interaction with the solid matrix, but that enzymes through cross linking they can have, this is very strong, this is also covalent binding, but that enzyme to enzyme binding also covalent binding. So, it is also strong binding, but they are not no interaction with the solid matrix like covalent binding. The cross linking, the covalent linking between the enzyme and enzyme. Now, let me tell you that this cross linking, that in this method, that immobilization enzymes are directly linked with covalent bond between the various group of polyfunctional agent. And what is the polyfunctional agent here? This is the glutaraldehyde. Now, what is the formula of glutaraldehyde? CHO, CH2, 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 CH. So, we have two CHO group. Am I right? So, this will bind with, this will form compound with amino groups of amino acids. Here, amino group of amino acids. So, how they are holding the enzyme together. Now, unlike other methods, no matrix or support involved in this method, because so it may be done in presence of matrix, it may be done without the presence of matrix. The polyfunctional reagents are the glutaraldehyde and diazonium salt, and cheap but not often used for the pure enzymes. Now, if you look at the advantage and disadvantage of this process, there is no leakage, highest stability, strong bound, and no hindrance to the active sites. Now, here disadvantage is complicated and expensive, and changes of active site and modification. So, these are the different problems that we face with the cross linking. Now, this is a very interesting table. Now, this table, they tell us that how you select the immobilization technique for your particular enzymes. Now, one thing I want to stress here, that all immobilization technique is not suitable for all enzymes. So, you have to select the enzymes, we select the immobilization technique on the basis of your requirement. Because this table, if you look at this, we have on the basis of certain characteristics, what actually we are looking for. As for example, suppose the preparation. So, first point is the preparation. What do you mean by preparation? Preparation, we mean that whether the methods of preparation is easy, what you are looking for, or it should be difficult. If it is simple, then it is easily. So, if one of the criteria for choosing the immobilization technique is that the preparation technique should be simple, then we should go for adsorption technique. This is the simple. But when you go for covalent or entrapment, it is very difficult, or membrane confinement, it is will be comparatively simple. But now if you look at the cost in case of adsorption, it will be low, and covalent will be high, entrapment will be moderate, and membrane confinement will be high. So, because if your cost criteria is more, then obviously you go for adsorption technique, because your monetary involvement is less. Now, binding force, will you want the strong binding between the solid matrix and the enzymes? Now, if you want strong bindings, then you should go for covalent binding and membrane confinement. But this is adsorption, binding force will be very weak, and this is variable, or it will be very weak. Now, enzyme leakage, what you want, that enzyme leakage should be no leakage of the enzyme, or you can prefer the leakage of the enzyme is permissible in your system. Now, if you want that there should not be any leakage in your system, then you go for covalent the technique, because covalent and membrane confinement technique. Otherwise, adsorption technique and entrapment technique, there is every possibility of leakage. Applicability means how widely it is applied. Now, adsorption widely it is applied. Then covalent binding is very selective. Particularly, this is used in case of the preparation of some biosensor, and this is the entrapment also widely used, and membrane confinement is very widely used. Running problem during the operation of the process, that what is the characteristics of that immobilization techniques, that is the running problem will be high, low, high, or high. If you want that running problem should be as low as possible, we should go for covalent binding techniques. Now, matrix effect, that whether this process is going to affect the matrix, that here is the yes, here is the yes, in covalent bonding is yes, entrapment yes, but in case of membrane confinement, no. So, now large diffusion barrier. Now, in case of adsorption, no diffusion and barrier, the covalent binding, no diffusion barrier, because your enzymes is there and it is outside, so your substrate can easily interact with the enzyme. But in case of entrapment, we have some diffusion barrier, and membrane entrapment, they inside. So, there will be every possibility that less diffusion of the substrate or less diffusion out of the product that will take place. Microbial protection, if you look at, now in case of adsorption, no microbial protection, because in case of adsorption, the outside the solid matrix, the enzymes are immobilized, there is no protection. In case of covalent also no protection, but entrapment, since it is inside, there is a protection for microbial attack, and here also membrane confinement, since it is inside the membrane, there will be some kind of protection for the microbial attack. So, it depends on what you are looking for. On the basis of your requirement, you should choose the technique. Now, next point that is important, how you characterize the immobilized enzyme. Now, because we have it usually presented by the international unit, and international unit is defined as that micromoles of substrate converted per minute per gram of immobilized enzyme. Now, activity of the immobilized enzyme is highly sensitive to initial substrate concentration of immobilized enzyme, temperature, pH, reaction time, agitation or flow rate, and physical dimension. One thing I mentioned in the last class also, that in case of immobilized system, suppose when you use the soluble enzyme, when you immobilize on a solid matrix. So, naturally it will convert it into solid the heterogeneous mixture, and since it is heterogeneous mixture, solid liquid mixture, so when you put it in a liquid solution, there is every possibility the solid will settle down at the bottom. So, you should require some kind of agitation, so the substrate can freely interact with the enzyme and keep the product. Now, bound enzyme, this is bound enzymes is very simple, that how much of protein is bound on the solid matrix. This is usually expressed as milligram of milligram of protein per gram of solid matrix. Now, specific activity of the bound enzyme protein can be expressed as micromole of substrate converted per minute per milligram of bound protein. This it provides some idea the effectiveness of immobilization procedure. So, you know that so this is how we can find out the activity of the immobilized enzyme. Now, finally, I want to tell you that immobilized system, there is a one thing that is called coupling yield or coupling efficiency. What do you mean by coupling efficiency? The overall, here you see the overall activity of the immobilized enzyme and overall activity of the initial enzyme solution present. So, what I showed you, suppose that this is the solid matrix, am I right? Now, this is here you put the solid matrix, here you have enzyme solution. So, initially the enzyme activity. Now, with the help of pump, you pass your solution like this and you recycle back like this. So, a time will come, your column will be totally saturated with enzyme. Then this activity will be constant. Let us assume this is activity is E1. So, how much enzyme is absorbed in the system? E1, E0 minus E1, am I right? So, this is like this, the overall activity immobilized. So, how much enzyme immobilized? E0 minus E1. How much initially it is present? E0. So, that ratio is called coupling yield. So, this is how we can easily find out. So, in this particular lecture, I try to discuss different immobilization techniques, and there are different, like we have the immobilization technique can be divided into two types, different types of immobilization techniques we have come across, and this selection is on the basis of the what kind of enzyme you are handling, the soluble enzyme or insoluble enzyme. So, on the basis of that, we have given the classification of the immobilization techniques. Now, what we have discussed, that what do you mean by adsorption technique, what do you mean by covalent immobilization technique, what do you mean by cross-linking technique, and what do you mean by membrane entrapment and hollow fiber entrapment. All this technique we try to discuss. Now, question come when you come to any kind of immobilization, which technique will be suitable for a particular enzyme, then you have to find out the criteria. What you are looking for, easy preparation, your binding force should be strong, or you can reuse the enzyme again and again. You want the microbial protection of the enzyme. So, on the basis of that, you can select what enzyme the enzyme immobilization technique you should use. And finally, I try to discuss how you can express the activity of the immobilized enzyme, both with respect to the solid matrix, with respect to the bound protein, and also I explain what do you mean by coupling efficiency of the immobilization system. Thank you very much.